Hey guys, welcome to my channel. It's Light It Up Tay with the Sparks and Skills, and today I'm going to show you guys what I learned in class. So what I have displayed right here is a reference that my instructor suggested, which is the uglies, and below we have a series circuit with some values inputted. So today I'm going to show you how to use Ohm's law while trying to solve for total current, total resistance, total EMF voltage, total power watts within a series circuit. So this is a series circuit right here. Okay, so our instructor, refer us to get this little Uglies electrical reference book. It's pretty much the Ohm's law will in the front of it. My class have it, the abbreviations are different. I would say wire instead of the pyre. Stop. But yeah, I was a little bit different, and pretty much you just got to try to remember the abbreviations. I try to associate E, V, like the sound, so I can just remember, right? Those two go together, and P and watts. It's like just try to associate them somehow. And the first few days I couldn't get it, but I got it after the fact. It's pretty simple once you get that part. So I'm also like, just getting a little Googling on, and I also see this thing called Ohm's law triangle. Pretty much, if you at least know where the V, I, R are placed, you won't even have to know any of the formulas to this, right? So pretty much, if you don't know what resistance is and you're looking for it, what I saw on YouTube, you just cover R because that's what you're looking for, and we have V and I left. So what you would do is, when you realize that V and I is left, you see that you have a line right here between them, so that would just look like a fraction and tell you to divide. So that's V divided by R. If you're already have voltage and you're looking for the current and the resistance, whatever you find, you cover it, and you have left I and R. So usually it's just like they're across from each other, so we just going to look at it as we're multiplying between the two. So it's I times R to look for V. And when you already know your current, you cover what you know, and you have left V and R, and you look at this as a fraction, and it will be said as V divided by R is how you would find your current. Okay, so right here I have the Ohm's law. I like to, put the abbreviation into what word associates with it, just to make it easier for me, being that I'm still learning, yet I am doing good at it, but just to help. And also I have some of the series circuit law. The one that I'm just going to really talk about more is the current. So the current is the same throughout the series circuit. So I made like a little reference chart for myself because I noticed that the voltage right here for Ohm's law, like each of these, the current, the resistance, and the power, the watts, like some of the series laws of like what they state, I could just like align it to each other in a way. So if you notice that. So back to the first part, how the current is throughout the whole series circuit. There's only one direction. It's not multiple directions within a series circuit. So with the current, the total current is going to equal to the first current. It's going to also equal to the second current. It's going to also equal to the third. So it's just always just going to be the same. And what I mean by this is that when we go back over here, if I current is equal to 1.5, it's going to be 1.5 across, 1.5 down, 1.5 across, in amps, measured in amps. Okay, so I made it bigger for me to, be creative here and try to be organized. So now what I like to do is put in information that I already know. So what we already know is the 20 volts total and the resistance total, because we have all the R1s labeled in ohms with some values. Okay, so we have the 20 volts, which are labeled here, EMF volts. Then with the resistance, you add each one due to the series law, and you got 40 ohms here. So typically with electrical work, electricity, Ohm's law, whatever the case, if you have two, you can always figure out the rest of what you need to know. If you don't have none, I don't think any work could be done, right? So we got two. We got the volts and we got the resistance. So now we need to look for the current. So I still stumble over that. So now we go to where current at, which is measuring amps. And I do not like to work hard. I'm not going to square root anything. I'm just going to work with the two. So we have all of this information. So we're going to go with this. Okay, so we use volts divided by resistance. We have 20 volts divided by 40 ohms equals 0.5 amps. So now we're going to work and find the power watts. So I already got ahead and made a boo-boo. We're looking for the watts. So you will reference back to your Ohm's law circle. I don't like to work too hard, so I'm going to use the E times I, volts times current. So you would go back here, 20 volts times 0.5 amps, and it will be 10 watts. So what I like to do is I start labeling things now, just to have some sort of reference to help me, adjust to learning this stuff. So we're going to find the voltage drop within resistor 1. So we have two information already. We have the amps and we have the ohms. So we're going to go back to this. We're looking for voltage. We're going to go to our chart. We're going to go to E and volts. We have these three problems. Again, I'm going to the easiest one. I'd rather multiply than divide, so I'm going to choose this one for the first resistor, and so forth and so forth. So for our voltage drop within each resistor, we have these. So R1 is 7.5, R2 is 2.5, and R3 is 10. So now what you would do is, okay, how do I know this is right? Well, total out of each part is 20. So we could just calculate this to make sure it's correct. So when we use our calculator, or if you do it in your head, you'll see that it equals to 20. So even if you get something like 19.9 or something that rounds off, or even 21, as long as it's close, that means it's right. It's pretty close. So now we're going to also find the power, the wattages across each resistor. And now we got a reference to this. I don't like to work too hard, so I'm going to use this formula right here. So this part could get a little tricky, because some people will be like, okay, so E, I'm going to go for volts. Sometimes they'll go back and use this volt. No, you go back and use the volts across each resistor, because we're calculating everything that's across each resistor. So you've used the total that you found within these right here. You don't use the overall total. You use what you found per resistor. So the first one, you're going to go to use 7.5. The second one, you're going to use 2.5. The third one, you're going to use 10. So now we know all of the watts, but how do we know this is correct? So we go back to the total, which is 40 watts, and we'll just add all of these and just see if it's correct. So when we add everything up, we get 10 watts, and it matched. Okay guys, so this was the series circuit, and just to backtrack, it's best to get your totals together and put in your known values. Then you work your way to your voltage drop and your wattages. So guys, if you have any questions, comments, compliments, please drop them, like, subscribe. This is Light It Up Tay with the sparks and skills. I'm here to support. I'm here to, you know, teach you everything that I learned, and I'm just here for you guys. So again, Light It Up Tay with the sparks and skills. Subscribe. Thank you for watching.